Hello, this video is about sensitivity analysis. It is the step that happens after we obtain the optimal solution. This chapter, we study the effect of changing the coefficient in the objective function, the amount of available resources, and even the resources themselves. In this video, we're going to be focusing on the coefficients in the objective function. In this example, they represent the profit rates of products 1, 2, and 3. Since we've started learning about formulation and linear programming, we have taken these coefficients as a given. In reality, though, these are only good estimates. They can very well change. So we need to study the effect of changing these coefficients on the optimality and feasibility of our optimal solution. So we could cope with these changes if they actually happen. Okay, so we have this optimal basis containing x3 and x2, and x1 is equal to 0. So let's start with studying the effect of changing the coefficient of x1, which is a non-basic variable. Well, when we have a non-basic variable, only the c-bar value of x1 will change. And to make sure that this basis remains optimal, we need to make sure that with the given change, this c-bar value will remain negative. Otherwise, it would have to enter the basis, and we would have to continue to the following simplex tableau. Okay, so let's call this change in the profit rate of product 1 delta P1. C-bar value of x1 is equal to -3. This C-bar value must remain negative after adding the delta P1, which could be an increase or a decrease, for the optimal solution to remain optimal. So -3 plus delta P1 has to remain negative. Hence, delta P1 must remain less than or equal to 3. So as long as the profit rate of product 1 does not increase beyond 6, which is the original profit rate, plus 3, the optimality is preserved. So if we increase its profit rate to 6.5 or 7, it would have to enter the basis because its C-bar row will become positive. Let's try it out. So this is 3. Let's add 6. Let's add 3. So here we have a case of alternate solutions. So x1 could as well enter the basis. Let's increase it beyond 6. So here we have 1. So now we no longer have an optimal solution. We would have to enter x1 into the basis and to continue to the next simplex tableau. Okay, so this is the case of a non-basic variable. It is not, however, the same for basic variables. So the basic variables here are x2 and x3. So what happens when we change the coefficients or the profit rates for x2 and x3? Well, it's not going to be the same as x1. We're not going to have changes only on the C-bar values of these two variables. It's actually going to cause changes in the C-bar values of the non-basic variables. So if there is a change to the coefficient of x2 in the objective function, we will have to the c-bar values of x1, s1, and s2 will change. And we need to check if these changes will make this basis non-optimal. So this is the formula we use to calculate the new c-bar value. It's equal to old c-bar value minus the row of the variable multiplied by the change, which we called delta P2, because we're talking about the change in the coefficient of x2. Okay, so this is the row of x2 in the optimal tableau, and this is the c-bar row. Now we need to check in which range that the c-bar values of the non-basic variables should be in for the current basis to remain optimal. So we calculate the new c-bar values for the non-basic variables x1, s1, and s2 following this formula. So for x1, it's equal to minus 3, which is the old value, minus the value in the row of x2, which is 1/2. It's right above the c-bar value of minus 3, and we'll multiply that by delta P2. So this value must remain negative for the current basis to remain optimal. Actually, these three should remain negative. Okay, so hence we conclude that delta P2 from the first equation has to be greater than or equal to minus 6 and less than 8, and also greater than or equal to minus 2. So we can conclude that this delta P2 has to remain between minus 2 and 8. So we can, as long as we decrease the profit rate of product 2 by 2 or less, by $2 or whatever units we're using, and as long as we keep the change between minus $2 and plus $8, this variation will not cause the optimal basis to become non-optimal.